Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have to calculate the area of a region, and the region is bounded by these two curves, y equals x plus 6 and y equals x squared. And we have to use a double integral of this form to find the area. Now, the very first thing that you should do when you have to find area bounded by two curves is first figure out where those two curves intersect. So let's find the points of intersection of these two curves first. So how to calculate points of intersection? You can do that by setting the two equations equal to each other. So we have x squared is equal to x plus 6. Now this is a quadratic, and in order to solve for x, bring all the terms on one side, set it equal to 0 and try to factor. So you have x squared minus x minus 6 is 0, and then factor. So look, this is negative 6, so 2 times 3 is 6, and we have a negative sign here, so it should be negative 3 and positive 2. So two factors will give us two different points. And the points are, from the first factor we have x equals 3, from the second one x equals negative 2. Now that we know where the curves intersect, the best way to understand the region is drawing the curves, and then we will see what area we have to calculate. Now notice that the first curve is a line and the second one is a parabola, and we all know how they look like. So this is your x squared, y equals x squared right here, and the line is y equals x plus 6. So roughly this is what the curve look like, and you see that the two of them, the region that's bounded by them is right here, and we have to calculate the area of that region. Also we know that they intersect at these 2 points, so this left intersecting point, that's negative 2, and the right one is 3. Okay. Now, come back here, and we have to set up this double integral to be able to evaluate this area. And remember, in order to do that, we first have to draw a rectangle inside the region. Now, this is a double integral, so there's dx and dy, right? dA is dx dy or dy dx. So it's up to you how you want to rewrite dA. Do you want x to be your outer variable, or do you want y to be your outer variable? Now, look at this region. Sometimes it's easier to do one way and not the other. Look at this region. What if you want to draw the rectangles horizontally, which means you want dy to be your outer variable? Notice if you do that, before I draw it, if you do draw the rectangle horizontally, the rectangle right here will look different than the one right below here. What do I mean by that? If you draw a rectangle here, see, it will be bounded by the 2 different curves, but down here is only the same curve. So the region's changing, right? And you have to separate the region first, and then you have to consider 2 different types of rectangles, and you have to rewrite all these equations in terms of x equals a function of y, and all of this has to be done. So looks like it's kind of complicated, right? Instead, if you draw the rectangle, say, vertically inside the region, it'll be the same looking rectangle everywhere. You see that? And it's much simpler that way. So let's choose this particular rectangle where the width is delta x, which means x is the outer variable. And then figure out the bounds for x and for y. Okay, so what are the bounds for x? X is between, look at the region, starting here, and here means negative 2, and ending at 3. So definitely x lies between negative 2 and 3. And when you calculated the points of intersection, that actually gave us the x bounds right there. Now look at the y bounds. Now y is between the two curves. The lower one is x square, the upper one is x plus 6. So it's between x square and x plus 6. Okay, so we have our bounds. Now let's rewrite this double integral. Remember, the outer integral is for x. So this one is -2 to 3. The inner one is for y. So x squared to x plus 6. And we have dy first and then dx, because dx is the x is the outer one. Now we just have to solve the integral and then we will find our area. Okay, so remember, to solve a double integral, you ignore the outer integral first, just evaluate the inside integral. And the inside integral is just dy, so antiderivative is y, and then you have to evaluate between x squared and x plus 6. So it's -2 to 3, plug in x plus 6 for y, then subtract and plug in x squared. And now we just have one integral in x. So antiderivative for x is x squared over 2. 6 will be 6x minus x cubed over 3. And then between -2 and 3, now you just plug in 3 and plug in -2 and subtract. Okay, so we have 3 squared over 2 plus 6 times 3 minus 3 cubed over 3. And subtract when you plug in -2 for x. So -2 squared over 2 plus 6 times -2 minus -2 cubed over 3. And now you can just pick up a calculator and calculate this value right here. Now notice you can, when you input the values, you can simplify. 3 squared is 9, 3 cubed is 27, and so on. So let's do that, and be careful with this negative sign here. This negative sign distributes, and also notice there's a -2. So be careful, right? -2 squared is positive, but here -2 cubed will be a negative. So be careful with all the signs, and the value is 125 over 6 square units, because this is area. So this is the area of the region bounded by these two curves, which is drawn right there. This completes the problem. Thank you.